Okay, for 5-5, our second problem set of our homework, that is problem set 10 through 16 evens. So in the second problem set, it says find all rational roots for p of x equals 0. Okay, for p of x equals 0, find all rational roots. So we're going to find all the rational roots for p of x equals 0. So we're going to go follow these instructions that says once you find one root. Okay, so let's do what we did on our last problem set until we find one of our p over q's that equals 0. So let's start. Let's find one root and then we'll look at the next thing. So this is what we're focusing on right now, finding one root. So let's do what we've been doing all along, which is looking at our p, which is 40, over q, which is 1. Right? So these are the two things we're going to look at. So factors of p and factors of q. So factors of p, well, all the factors of 40, we've got 1 times 40, 2 times 20, 3 doesn't go, 4 goes, times 10, 5 times 8 is 40, 6 isn't evenly in there, 7's not evenly in there, and then we're back to 8. So there it flip-flops. 8 times 5, 10 times 4, 20 times 2, and 40 times 1. So these are all of our factors of 40. So you see how this can get very tedious checking for zeros very quickly. So for factors of 40 for our p is going to be 1, 2, 4, 5. Oh, by the way, positive, negative on all these. Okay, and positive, so positive, negative 8, positive, negative 10, positive, negative 20, and positive, negative 40. There's all the factors of 40. Now, luckily, we just have a 1 for the coefficient of our q. So all we have to deal with is 1. So now we've got all of our possible p's and our q's, the factors. Now let's get all of our possible rational roots, which is p over q. Okay, now to do that, we're going to take all our p values, positive and negative, and put them over q. Well, in this instance, our q is 1. So everything over 1 is just itself. So all of the p's over q's, we would have had 1 over 1. Positive and negative 1 over 1. Positive and negative 2 over 1. Positive and negative 4 over 1. So I'm not even going to deal with that. All of these over 1 is just going to be the number themselves. So all of these are going to be positive, negative 1, positive, negative 2, positive, negative 4, positive, negative 5, positive, negative 8, positive, negative 10, positive, negative 20, and positive, negative 40. So there's all my possibles. Now, what we have to do is find the first root that gives us 0, the first possibility that gives us a 0, and that will be our first root. Okay? So that's the thing. We're still doing exactly what we've done, but as soon as we get this first 0, we're going to stop and do something different. Because to check all of these, how many do we have? We have, let's see, 2 checks, 4, 6, 8, 10, 12, 14, 16. We would have to check 16 different numbers. And that would get very tedious. So there's a quicker way to do this. So that's where it's going to differ from our first problem set. So let's continue to find our first 0. So we'll just start from the smaller numbers and work our way up. Let me get the problem set again. Right there. Oops. Well, I'll just rewrite it. So our problem is p of x equals, and I'll just do the 1x cubed plus 14x squared plus 53x plus 40. Okay, so let me group that. So let's do the first one, p of positive 1. And that's going to be equal to 1 times 1 cubed plus 14 times 1 squared plus 53 times 1 plus 40. Well, I can see right away this is not going to equal 0 because we've got a 1 times a 1. 1 cubed is 1, so this is going to be 1. 1 squared is 1 times 14 is 14, so we've got 1 and 14, that's 15, and this is going to be a positive number, and that's a positive number, so it's just going to get bigger and bigger. So p of 1 is not a 0 of our equation. So that does not check out. So you might want to do something to keep a little tally. So I would just circle it and say no. Now let's check the negative one. What's p of negative 1? Now I'm going to say 1 times negative 1 cubed plus 14 times negative 1 squared plus 53 times negative 1 plus 40. Possibly might work. Let's see. Negative 1 cubed is just negative, so this becomes negative 1. 14 negative 1 squared is positive, so we have a plus 14. 53 times negative 1 is negative 53, and then 40. So what do we have? We have, let's see, negative 53 and negative 1, that's going to be a negative 54, and then 40 plus 14 is a positive 54. Negative 54 plus positive 54, yay, yay, it's a 0. We've got our first 0. So look, out of all those 16, we only had to go through 2. 0, our 0 was our negative 1. Okay, so that's our first step. We got our first actual root of negative 1. Okay? Now the next thing they say is use synthetic division to factor the polynomial. So let's do this. Okay, so now that we've got our first 0, we're now going to use synthetic division because that's what the next step says. Use synthetic division to factor the polynomial. And we're going to take it, do the synthetic division using our 0 that we just got, the negative 1. So let's do that next. Delete this. Okay, so now we're going to go a negative 1. That was our 0, our root. We found our root. Now we're going to use synthetic division to start whittling this down. So now we're going to do, let's see, a 1, a 14. Oh, and we have 3, 2, x to the first power and x to the 0 power. So they're all represented, so we don't have to put any zeros for placeholders. So we've got a 1, a 14, a 53, and a 40. Okay. I like to keep these nice and clean. All right, so now let's use synthetic division and see what we get here. So we start by carrying down our first term, 1, and multiply by what's in the box. 1 times negative 1 is negative 1. Now add. Okay, 14 plus negative 1 is a 13. And next, we're going to do 13 times negative 1, what's in the box, and we get a negative 13. Well, 53 minus 13 is 40. Okay. And now 40 times negative 1 is negative 40. And that goes to 0. So if we looked at our instructions here, it said continue finding roots and dividing. So you repeat this process over and over until you have a second degree polynomial. Then, when you get a second degree polynomial, you just factor that using your factoring things that we've learned or your quadratic formula to find your last roots. So let's see, do we have a second degree polynomial here? It sure looks like it. So that would be our remainder. That's our constant. This is our x, and that's our x squared. So yes, we have a quadratic. It's going to be x squared plus 13x plus 40, okay, with the remainder of 0. So now, can we factor this? Let's see if we can use our magic x. What two factors of 40 add up to be 13? How about 8 and 5? That's it. So we've got x plus 8 times x plus 5. So what makes those equal to 0? Well, when x is negative 8 and negative 5. So our first root was negative 1, and our other roots are negative 8 and negative 5. So when they ask for all of the possible roots, this is our answer. Okay, and you might want to put them in order from least to greatest. So it would be a negative 8, negative 5, and negative 1. Okay, and that's probably how it would be on the test answer choices. Okay, and that's how you do these. And thank you for watching, and do the rest of your homework now that I've done about a half of it, maybe, not quite a half. And we'll see you tomorrow. Thank you.